So we need to relate these variables mathematically. This is a law, a mathematical expression relating variables known as Ohm's law, and it basically says this: as long as your resistance is constant, the voltage and the current will be directly related to each other. That makes a lot of good sense to me. Think about it. Let's say that I have a circuit just like this, and my resistance is constant. So I have voltage, I have current, and I have resistance. Let's say that my resistance is 1 ohm or something like that. And let's say that this battery is a 6-volt battery. So my voltage is 6 volts. What is my current going to be? Well, according to this equation, V equals IR, 6 equals the current times the resistance of 1, V equals IR. My current here is going to be 6. What happens if I replace this battery with a 9-volt battery? So instead of a 6-volt, I have a 9-volt. What's that going to do to my current? V equals IR. 9 equals I times the resistor of 1, resistance of 1 ohm. My current is going to be 9. By the way, what's the unit for current? It's amps, right? So this makes perfect sense. If the voltage goes up, the current also goes up as long as the resistance stays the same. This makes sense too based on the definition of these terms. The current is kind of a measurement of the flow of the electrons. And what's causing the electrons to flow in the first place? It's the voltage, right? So if I have a larger voltage, I'm going to have a larger flow of electrons as long as the resistance doesn't change. Smaller voltage, a smaller flow of electrons. If those electrons are feeling less potential energy, if they've been pumped to a lower elevation, so to speak, if water has a lower pressure, it's going to be flowing more slowly. So same with electrons, lower voltage, lower current, higher voltage, higher current. That makes pretty good sense. We can also think about it like this. As long as the voltage stays constant, the resistance and the current, the I and the R, are inversely related. That means as one goes up, the other one goes down. So let's think about this. Let's say that I have a circuit like this with a 9-volt battery. And let's say that I have a resistor whose resistance is 1 ohm, just like last time. What is the current going to be flowing through here? Well, V equals IR. My V is 9. I don't know my current. I'm trying to find it. And my R is 1. Once again, the current there is going to be 9 amps. What if I change this to a 3 ohm resistor? So I've increased the resistance. V equals I times R. My resistance is now 3. What is my new current going to be? It's clearly going to be 3 amps. My current has gone down. That makes perfect sense. Once again, based on the definition of these terms, current is the flow of electrons. Resistance is a measurement of how the circuit is resisting that flow. So if I have a higher resistance, more resistance to flow, I'm going to have less flow. That makes perfect sense. So Ohm's law, I think, makes a lot of good intuitive sense based on the definitions of these terms. And Ohm's law is given thusly: V equals I times R. Finally, we're going to talk about what happens if you have more than one resistor in your circuit, circuits with multiple resistors. There are two ways, it turns out, to connect multiple resistors in a circuit. You can add them in series or you can add them in parallel. So here's the definition of a series circuit. This is where your resistors are connected in a row, one right after the other. So it would look something like this. Here's a resistor. Maybe this is a string of light bulbs or something, Christmas lights, with light bulbs all together in a row. So here's a circuit that has 3 resistors. I might call them R1, R2, R3. What it means for them to be in series, think about your favorite TV series. What does that mean? It means that one episode comes right after the other. So one resistor comes right after the other, all connected in a row with each other. Here's my voltage, here's my current. So what do you think the effects are going to be of adding more and more resistors to the circuit? Well, it's pretty clear. More resistors means more total resistance. The total resistance is simply the resistances added together. And so Ohm's law still takes effect, V equals IR, but now I'm looking at the total of all the resistors added together. So if I keep adding more resistors, what's going to happen? My current is going to drop. Remember, current and resistance are inversely related. Um, so add more resistors, have more total resistance, my current's going to go down. There is a major disadvantage to connecting multiple resistors in series, which is this. If any one resistor malfunctions, the whole circuit shuts down. So let's imagine that these are Christmas lights and that this guy has burned out, has malfunctioned. Well, it turns out that when light bulbs burn out, um, their filament breaks and they're no longer capable of conducting electricity through them. So really this resistor would kind of be like this. It would be broken and oh my gosh, what do I have now? I have a gap in my circuit. This is what I would refer to as an open circuit. And think about this. Are these light bulbs going to be lit up? And the answer is no. What is the only way for electricity, for electrons to flow? There's got to be what? A closed loop, right? Well, I don't have a closed loop. I have an open loop. It's been broken, so I'm not going to have any current flowing at all. This is an open circuit. I'm not going to have electricity here. However, if we replace that light bulb and we fix the resistor, this is no longer an open circuit. Do you know what we would call this? We would call it a closed circuit because everything is connected. It is a closed loop. Am I going to have current now? I sure am. So now current is going to be flowing again around the circuit. It's a closed circuit. Yay. So it's bad news bears if you have resistors connected in series and one of them malfunctions, you're kind of out of luck. The whole thing shuts down. So to avoid that, we will often connect resistors not in series but in parallel, which basically means that our resistors are connected in branching paths. So here's what it would look like for three resistors to be connected in parallel. Here's one resistor, and for every new resistor, I'm just adding a new path. Here's another resistor, and then here's my third resistor. You can see, so V, R1, R2, R3. My current now has basically three pathways to flow down. It can flow down the path of R1, it can flow down the path of R2, it can flow down the path of R3. Interesting things happen when you start adding resistors in parallel with each other. Adding more resistors here, completely opposite of adding them in series. Adding them in parallel makes the total current of your system increase. It actually causes the total current to increase. This is a little bit counterintuitive, but if you think about it for a moment, it kind of makes sense. Why would the total amount of electron flow, the total current, increase here as I add more pathways, as I add more resistors? Well, it's because I've kind of opened up new lanes of traffic. Remember, current is like electrons flowing. So if I've just added multiple paths, multiple lanes of traffic for the electrons to flow, then overall, the electrons are going to be flowing more throughout the whole system. It works really just like a toll booth. So imagine that you're driving through Oklahoma on those toll roads. Which one would you rather drive through? Look at these two on the right. Would you rather drive through a tollway that made you stop one right after the other, slowing down traffic thusly? No, you would hate that. It would go so slow. Every single car would have to stop here and stop here and stop here, and it would take forever. Your current, your traffic flow would be so slow. And the more you added, the more toll booths you added, the slower and slower the traffic would be. You'd have big traffic jams. So the smarter idea is to not add them one right after the other in series, but to add multiple branching pathways. Pathway number 1, pathway 2, pathway 3. to add them in parallel. Now the traffic overall is going to be flowing much more quickly because there are multiple branching paths for traffic to take. Let's go back to this example. Let's imagine that this second toll road somehow malfunctions. It falls apart. A giant pothole opens up, something. Is any traffic going to be able to flow now at all? No, the whole system shuts down. Let's say in this example that this second pathway shuts down for some reason. Can traffic still flow? Yeah, it sure can. It can flow through these other pathways. So there are some advantages to allowing resistors to be in parallel with each other. More paths, more resistors in parallel makes the whole system, makes the whole current actually increase, which is counterintuitive. I'm not going to have you analyze parallel resistors mathematically using Ohm's law, but you will have to analyze series um, circuits mathematically using Ohm's law, which I mentioned right here. V equals IR, but now you're adding up all the resistors in your series.